Welcome back, everyone, to the deep dive. We often see data just kind of sitting there in tables, all those rows and columns of numbers. It can feel a little bit like being back in school staring at a textbook.
Yeah,
Yeah.
definitely. Tables aren't always the most exciting way to look at information.
Exactly. But today, we're going to dive into a way to make that data come alive. We're talking about graphs, and specifically, the power of line graphs. It's like taking those static numbers and turning them into a moving picture.
I like that, a moving picture, because that's what a good line graph does, right? It shows you trends and comparisons in a way that's so much easier to grasp than just looking at raw numbers.
Right. And for this deep dive, we're really focusing on how line graphs help us understand data that's constantly changing, like over time.
Exactly. That continuous change is where line graphs really shine.
Okay, so let's start with a simple example. Imagine someone, let's say her name is Renew, and she's not feeling so well. So throughout the day, someone takes her temperature a few times.
Okay, I can picture that.
So think about a graph where the horizontal line, our time track, shows the hours of the day, and the vertical line, our temperature track, shows her temperature readings in Celsius.
All right, got it. Our axes are set up, time on the horizontal, temperature on the vertical.
Perfect. Now let's say it's 6 a.m., the thermometer reads 7 degrees. Then by 10 a.m., it's climbed up to 40 degrees. At 2 p.m., it's back down to 38, and by 6 p.m., it's settled at 35.
So if we take those four readings and plot them as points on our graph, 6 a.m. at 37 degrees, 10 a.m. at 40 degrees, and so on, and then connect those points with lines.
We get a visual story of how Renew's temperature changed throughout the day, right?
Exactly. And you can instantly see things like the highest point in the morning and that gradual cooling down as the day went on.
And it also makes it super clear, just by looking, that her temperature jumped up by 3 degrees between 6 a.m. and 10 a.m.
Right, you can see those changes so easily.
But here's where it gets even more interesting. Our source material points out something really cool. Even though no one took Renew's temperature at, say, 8 a.m., the graph suggests it was probably higher than 37 degrees. How can we tell that just from the shape of the line?
Ah, that's a great question. It gets to the heart of why these visuals are so powerful. We can see that the line connecting 6 a.m. and 10 a.m. is steadily climbing, right? So even though we don't have an exact measurement for 8 a.m., we can assume her temperature was following that upward trend.
So we're making an educated guess based on the information we have.
Precisely. It's called interpolation. We're filling in the gaps, so to speak, using the existing data and the overall trend.
Okay, I'm starting to see how much we can learn just from the shape of a line. And speaking of comparisons, let's move to another example, cricket scores. Imagine we're looking at the runs scored by two batsmen, Batsman A and Batsman B, over 10 matches in 2007.
All right, love a good cricket analogy.
Me too. So our horizontal match track goes from 1 to 10, representing each match. And our vertical track, naturally, shows the runs scored in each match. To make things clear, let's say Batsman A's performance is shown with a dotted line.
Dotted line for batsman A, got it.
Now what's cool is that just by looking at this graph, we can immediately see how the two batsmen performed relative to each other.
Yeah, because their scores are literally side by side on the graph, right?
Yesly. For instance, if you look at the fourth match, you'll notice that both lines, the dotted line for batsman A and the solid line for batsman B, meet at the same height on the runs track.
So that means they both scored the same number of runs in that match.
Got it. And if you look closely, you can see that they both scored 60 runs.
Pretty neat how the graph gives you that information instantly.
Totally. But the graph shows us so much more than just individual scores. It tells a story about their consistency, or lack thereof. Batsman A's dotted line is all over the place, high peaks, like a top score of 115.
Wow, 115, that's impressive.
It is. But then he also has some really low dips, including a couple of matches where he got out for a duck, no runs at all. In 5 matches, he didn't even reach 40 runs.
So a bit of a roller coaster performance, you might say.
Totally unpredictable.
Yeah.
Now look at Batsman B's solid line. It's much smoother. His lowest score never dips below 40, and his highest is a solid 100.
Ah, so even though batsman A had those big scoring moments, batsman B was the more consistent player overall.
Exactly. The graph shows that beautifully. It highlights the contrast between a volatile performance and a steady one.
Really cool how that visual difference tells us so much.
Okay, let's shift gears from cricket to a car journey. Imagine a car driving from city P to city Q, a distance of 350 kilometers.
Okay, I'm picturing a scenic road trip.
Now we have a graph that tracks the car's distance from city P over time.
So time on the horizontal, distance from city P on the vertical.
Exactly. And this graph unfolds the entire journey for us. Right at the beginning, at 8 a.m., the line starts at 0 kilometers.
Which makes sense because the car's still at City P, hasn't moved yet.
Right. Now follow that line. By 9 a.m., the car has covered 50 kilometers. But then in the next hour, between 9 a.m. and 10 a.m., the line gets steeper. It shoots up to 150 kilometers away from City P. That means they covered 100 kilometers in that hour.
Zooming along. But hold on, what about the next hour?
Good observation. Between 10 a.m. and 11 a.m., the line is less steep. They only covered another 50 kilometers, reaching 200 kilometers from City P.
So their speed must have changed during those 3 hours, right? Because the steepness of the line tells us how much distance they cover over the same amount of time.
Exactly. And here's something else. Look what happens between 11 a.m. and 12 noon. That line goes completely flat, staying at 200 kilometers.
A flat line, what does that tell us?
Well, if the distance isn't changing, even though time is passing.
They must have stopped somewhere, a pit stop maybe.
Exactly. A lunch break, maybe. The graph clearly shows that the car was stationary for that whole hour, 200 kilometers away from City P. And finally, we see the line reaching 350 kilometers, which is City Q, at 2 p.m. That marks the end of the journey.
So the graph gives us the whole picture, from start to finish, including that stop along the way. Amazing how much detail it captures.
Right, and think about it. In just these 3 examples, Renu's temperature, the cricket scores, and the car trip, we already learned so much about how line graphs can show change over time, compare different things, and even reveal patterns of movement.
It's incredible how they bring the data to life in a way that just looking at numbers can't quite do.
Absolutely. And our source material points to exercise 13.1, which gives even more examples of how line graphs are used in the real world. There's stuff like tracking a patient's temperature over time, visualizing a company's yearly sales, charting the growth of plants, seeing how temperature forecasts compare to the actual temperatures, and even following a courier's route. It really shows how widely applicable these graphs are.
Totally, they're everywhere once you start looking for them.
Okay, let's dig a little deeper into how these graphs actually work. The text talks about independent and dependent variables.
Ah, yes, those terms. They might sound a bit technical, but they're actually pretty easy to understand.
They are. It's all about cause and effect. Like, think about your electricity bill.
Yeah.
What do you have control over that directly affects how much you have to pay?
Well, the amount of electricity I use, right? How many lights I have on, how long I run the AC, things like that.
Exactly. That's the independent variable, the thing you have some control over, and the amount of your bill. That's the dependent variable. It depends directly on how much electricity you've used.
So the graph becomes a way to visualize how those two things are connected.
Exactly. And here's a perfect example from the text. Buying petrol. There's a table showing that 10 liters of petrol cost $500, 15 liters cost $750, 20 liters cost $1,000, and 25 liters cost $1,250.
Okay, I can picture that table.
Now, if you were to plot those points on a graph, with the number of liters on the horizontal input track and the cost on the vertical output track, you'd get a straight line.
A straight line, interesting.
And what's really cool is that this straight line goes right through the point where both our axes start, the origin of the graph. The text asks you to think about why that might be.
Why does it go through the origin?
Well, think about it. If you buy 0 liters of petrol, how much do you pay?
0 rupees, of course.
Exactly. That's why the line starts at 0 for both liters and cost. It's a direct relationship. As one thing increases, the other increases at a steady rate, and they both start at 0. It's called direct variation, and a lot of times it shows up as a straight line through the origin on a graph.
That makes sense. And it's not just a theoretical thing. You could actually use that graph to estimate costs, right?
Absolutely. For example, say you wanted to buy 12 liters of petrol. Find 12 on that liters axis, follow it straight up until you hit your plotted line, and then go straight across to the cost axis. That'll give you a good estimate of the price.
So it's like a visual calculator.
Exactly. And this idea of showing financial relationships visually continues with the next example, simple interest. Imagine a bank offers a 10% annual interest rate on deposits for senior citizens.
Okay, a nice perk for senior citizens.
They have a table that shows how much interest you'd earn after 1 year based on different deposit amounts, like 100 earns 10 interest, 200 earns 20 interest, and so on, up to even 1,000 earning 100 interest.
I see, so a simple, straightforward interest calculation.
Right, and just like with the petrol example, if you plot those data points on a graph deposit amount on the horizontal track, interest earned on the vertical, you get another straight line.
Another straight line, interesting. So does this one also pass through the origin?
It does, because logically, if you deposit 0 rupees, you'd earn 0 rupees in interest.
Right, makes sense.
The example even tells you the scale they use for the graph, which is important for representing the data accurately. And this graph becomes a handy tool. You could easily figure out that a deposit of 250 would earn you 25 in interest. Or if you wanted to earn, say, 70 in interest, you could find that on the graph and see that you'd need to deposit 700 dash.
It's like a visual cheat sheet for calculating interest.
Exactly. And it's another case of direct variation.
Hmm.
The more you deposit, the more interest you earn, and that steady relationship is shown by the straight line.
The power of visuals.
For our last in-depth example, let's picture Ajit taking a scooter ride. He's riding at a constant speed of 30 kilometers per hour. The table shows that after 1 hour, he's traveled 30 kilometers, after 2 hours, 60 kilometers, and so on.
Okay, so a nice steady pace on the scooter.
And if we graph this time-distance relationship, time on the horizontal, distance on the vertical, we get, surprise, surprise, another straight line.
They do love their straight lines in these examples.
They really do. It's a great way to visualize that constant rate of change. And just like before, the example tells us the scale they used for this graph. Once again, this visual representation makes it super easy to answer questions about the journey.
Like how long would it take him to travel a certain distance, or how far he'd go in a specific time?
Exactly. We can see from the graph that it would take Ajit 2.5 hours to travel 75 kilometers. Or that in 3.5 hours, he would have covered 105 kilometers. It's all right there in the graph.
Really makes those calculations intuitive.
So we've explored all sorts of scenarios today, from basic things like tracking temperature to understanding financial concepts and even analyzing movement.
And in each example, we've seen how line graphs can be incredibly useful for showing us the relationship between two things, especially when one changes in relation to the other.
And to wrap things up, the text mentions exercise 13.2, which gives you a chance to try your hand at drawing graphs from tables. They give you data on things like the cost of apples, the distance a car travels, and the interest earned on deposits. And they even ask you to think about whether certain relationships, like the perimeter and area of a square as its side length increases, would result in straight lines or not.
A good way to test your understanding and apply these concepts.
Totally. So as we reach the end of our deep dive into line graphs, what are the big takeaways you hope our listeners will remember?
Well, I think the main point is that line graphs are a fantastic tool for visualizing data that changes over time. They can help you quickly identify trends, compare different sets of data, and understand how two things are related.
Right. And we've seen that those relationships can be linear, like a straight line, or nonlinear, meaning a curved line. It all depends on how the variables interact. And today, we explored a wide range of practical uses for line graphs, from something as personal as monitoring a fever to comparing the performance of athletes, understanding a car journey, figuring out costs, and even getting a visual grasp on financial ideas like simple interest. Line graphs truly are all around us, helping us make sense of the world.
They really empower us to move beyond those static tables of numbers and see the stories that the data is trying to tell.
Exactly. And with that, we leave you with one final thought to ponder. Think about everyday situations where one thing influences another. How might sketching a simple line graph help you understand that relationship better? Maybe it's the amount of sleep you get and how alert you feel throughout the day. Or maybe it's the amount of time you spend practicing a musical instrument and how your skill improves.
Great examples.
What insights might you gain by actually plotting that data on a graph? It's all about uncovering those hidden connections that might surprise you.
Food for thought. I like it.
Thanks for joining us on this deep dive, everyone. Until next time.
See you then.